What's up, guys, gals, and everything in between? Today we're talking about simplifying rational expressions. Right here, I want to simplify this a different way. So I'm actually going to split apart this 20 and this 14 by factoring it. So I'm going to factor that 20 into 2 times 10 and that 14 into 2 times 7 because they both share a factor of 2. And then I'm also going to split this x to the 6th into x to the 4th times x squared, so that I can see what I can simplify. So I can cancel out these x to the 4ths because they divide out to 1, and I can also cancel out those 2's because they divide out to 1. So I'm left with 10x squared over 7. So there's an exponent law here that you might remember from Algebra 1, is that when we are dividing the same base, we can subtract those exponents. So here we could have just done 6 minus 4 is 2, so this would be x squared when simplified. So we put the x squared in the numerator here because the x to the 6th was bigger, it had more x's. So we'll look at an example next that has more x's in the denominator. Okay, so here I'm going to use that same strategy as I used in the first example. I know that 30 is 2 times 15, so I'm going to rewrite that 15 in the numerator, and I'm going to factor that 30 into 15 times 2. And then I want to try my new trick, or I guess my old trick that I'm remembering, that I can subtract these exponents. 5 minus 10 is going to give me x to the negative 5. So let's talk about what happens here. So a negative exponent is very sad where it lives. It can only live in the numerator or the denominator. So once you change its location, it's not sad anymore, it's positive. So here I just changed that x to the 10th into x to the 5th times x to the 5th. So you can see that my answer here would have that x to the 5th down in the denominator. And that's because when you do 5 minus 10, you get a negative exponent. So it needs to live in the denominator. So an example in a different way is if you were stuck with a negative in the denominator, you would move it to the numerator and the exponent would no longer be negative. So you do want to subtract the exponents, but you want to put your answer wherever the exponent was bigger in the original expression. So here is one to try. Notice how you have numbers, x's, and y's. Remember, when you subtract those exponents, you want to put the answer where the bigger exponent used to live. Go ahead and pause the video here, try this, and come back when you're finished. So notice this setup here. I split up that 64 into 16 times 4. And then notice how I wrote x to the 19 minus 7 in the numerator. And I wrote y to the 12 minus 3 in the denominator. That is no coincidence. That is because you would leave your answer for x in the numerator because you have 19 x's at the top. And you would leave your answer for y to the 12th minus 3 in the denominator because you have more y's in the denominator. If you think of it this way and just subtract those exponents like you would naturally to get positive answers, then you don't have to think about those weird negative exponents so much. You just put your answer where more variables lived in the original. So we're going to leave monomial land and head on over into binomial land. Here I still want to factor, but here I'm factoring out a GCF from a binomial, and I'm left with x minus 2 when I factor out that 6. These are exactly the same, so I'm going to cancel those like quantities. In this next example, we have a difference of squares in the numerator. My kids struggle so hard with these difference of squares. These are the easiest ones to factor because you have an x squared, a minus sign, you have a perfect square, you just factor it into the square root of the first term, plus or minus the square root of the last term. Now, in the denominator, it almost looks like one of these quantities, but the signs are wrong. So if I factor out a negative here, that positive 5 will become a negative 5, and that negative x will become a positive x. So I can switch the order around. So this is a common thing that happens. Like, that term almost looks exactly the same, but even if I switch it around, the signs are wrong. So if the signs are wrong, you want to factor out a negative 1, and that will change the signs of both of those terms in your factor. Now that I have these quantities that look exactly the same, this x minus 5 over x minus 5, I can cancel those like quantities out. I don't want to leave that negative in the denominator, so I'll just move it to the numerator. It's just a negative 1, and this is my final answer. I want you to take that same idea and I want you to factor the numerator and the denominator in this question. You're going to have to pull out some old school factoring skills like factoring out a GCF, maybe split the middle term, maybe figure out what factors multiply together to give you the last term, but add together to give you the middle term. So pull out that factor and flow chart and pause the video, try these, and come back when you're done. All right, so super nice GCF in the numerator here of 4x. And in the denominator, once I take out that GCF of 2, I can just factor using cheeks. 3 times negative 1 is negative 3, and 3 minus 1 is 2. In the numerator, I just did a quick 4 divided by 2 is 2, so that left me with 2x in the numerator. I canceled out those quantities of x minus 1, and then I have x plus 3 left over in the denominator. Here's my answer. All right, so here I do not like to teach multiplying rational expressions separately. We're going to try to factor everything completely and then cancel any like quantities or reduce any fractions. So right now, I want you to look at these 3 ratios. My pen's dying. And I want you to factor absolutely everything. And then when we come back, we'll check those factors. All right, so I factored absolutely everything except for that denominator because I wanted to go over split the middle term one more time. So you're first going to start by multiplying the first and last terms together. You get negative 20x squared. You want to find all of the factors of negative 20x. So I start with the positives and then I look at my signs. So the negative 10 tells me that my signs are different. And then that negative x tells me that my bigger sign is negative. So I'm looking for the ones that add up to negative 1, which would be 4x minus 5x. So I'm splitting that middle term and I'm rewriting the first and last term where they were. Then I can group them 2 at a time, factor out a GCF from each group, and then those groups that are left over should be exactly the same. That's my first factor, and then whatever's left is my other factor. So 2x minus 5 is my other factor here. Real quick, in the numerator of that first ratio, 3 times 1 gives you the last term, and 3 plus 1 gives you the middle term. So that's why that's x plus 3 times x plus 1. Middle ratio here, you just had to factor out a GCF from both numerator and denominator. And then the denominator at the end, you have the same thing where you have 2 times 1 is 2, but 2 plus 1 is 3. So here's where we have to cancel like quantities. We are looking for like quantities where you have 1 in the numerator and 1 in the denominator. So I have an x plus 3 in the numerator and an x plus 3 in the denominator, which I can cancel out. I don't have a 1 plus 2x or a 2x plus 1. I do have a x plus 1 and an x plus 1. I can't cancel those x plus 2s because they're both in the denominator. I can also reduce these two x's. X over x cancels out as well. And now I'm just going to write down what's left. So I have a 2x squared in the numerator and a 1 plus 2x, which I'm just going to kind of flip around to be 2x plus 1. It just looks nicer like that when it's in standard form. And then I'm going to write x plus 2 squared because there are 2 of those, and 2x minus 5. I don't want to multiply those back out. It would just be a waste of time. So leave them in factored form. All right, so now I want you to try one. Factor absolutely everything, cancel any like quantities where you have the same quantity in the numerator and the denominator, and come back when you're done. All right, so take a minute to check your factors. That difference of squares, x squared minus 4, that factors into x minus 2, x plus 2 always gets my kids. So check that one. Make sure you got it. I'm going to cancel like quantities. So x plus 1 in the numerator and the denominator. I have an x minus 2 in the denominator and an x minus 2 in the numerator. And I have no other terms that are exactly the same. I have x minus 4 and x plus 4. Those are not the same. They have two different signs. They are not the same factor. So I cannot cancel them out. I cannot magically cancel out the 4s. I cannot magically divide by 2 or anything like that. So here I have these two factors in the numerator and these two factors in the denominator left over. That's my answer. See you next time. Have a great day.